So yes, in the last video we discussed some important points of the electropermittivity and relative permittivity, but the half was remaining, so we are going to discuss in this video. Okay, so if we have K is equal to 1 upon that was the first part, this would be the second part, so I would suggest you to watch that first to know this concept. So if we have the formula of this, like it's simply a formula, okay, which is about vacuum and air, we can say vacuum or air. Okay, so permittivity. So here we have, like, if this is the electropermittivity, which value is 8.8 multiply 10 is power 12, 10 is power 12 coulomb square into Newton meter square. So yes, if you have this question, then K simply value is around 9 into 10 power 9 Newton meter square. Then here will be Newton meter square into Coulomb square. Okay, so here ER is like relativity permittivity, which have no unit. Okay, no unit of electropermittivity. There's a relative permittivity. Then how, like, why they don't have any unit? Just because ER is simply a ratio. It's a ratio. And if we just talk about its formula, so it's like force, or no force, but F force, and here we have ER, force into velocity or force into medium we have. So force, if you just whenever you just get force, this means that unit is Newton, and down is also force into medium, so they will just cancel each other. So this means there's no unit, this is simply a ratio. Okay, so yes, and we always has her, like, this formula I'm just writing is according to Coulomb's law. K Q1 Q2 upon R square okay. So here K is value, like exact K value would be 1 4 pi into electropermittivity ER. If we just write ER, this simply means it don't have any unit. And if it's 1, like, we can call this as air permittivity, just because we discussed in the last video about air, water, wood, their permittivity. So this 1 was about air. Okay, 1 was about air. So 4 pi into, we can simply call this as, the Coulomb's law can simply be written as this formula as well. Okay, so if we just separate these both, this would be F, this will be 1 4 pi epsilon, relativity permittivity, which is equal to charges Q1 upon Q2 upon R square. You know, R square is the distance, the square of the distance between them. This is the magnitude of charges. Here we represent Q1 and Q2, which shows we have two charges and they are denoted by Q1 and Q2. So this